So let's lay some ground rules. We would like to know what problems you're facing. So as we go along, you can interrupt us. You can divert us somewhat off topic as long as it's not too far. The basic premise of this session is that we built this thing called the Autonomous REST Connector. And between that and some of the experience we've had with software as a service data sources, we spent a lot of time dealing in the REST world. So what we'd like to do is share some of what we've discovered, the problems that you run into going from small scale to large scale. And as you see things, please feel free to interrupt us and ask questions. That's one of the reasons it's a double length session. By the end of it, if there are things that you would like to see that we're not doing, if you have ideas, we have been encouraged by product management to ask and write them down and bring them back. So you have an opportunity to shape what we're doing. We will not give you delivery dates, but we will at least think about it. So I'm Tony. This is Phil. Eventually we'll get slides
I'm the
again.
one breaking the slides. There we go.
All right. And so what are we doing here? We're here so I can go to Disney next week and not have to pay for my flight.
True story.
Yeah, it's actually not the whole reason I'm here, but part of it. So why are we talking about REST? It's, well, either your application is providing data and you've decided REST is a good way because it's fairly inexpensive, there's a lot of good infrastructure that we'll talk about, or you're consuming data, or at least you would like to consume data. There's a lot of REST endpoints out there on third-party apps, there's public REST APIs, so in or out. The APIs are everywhere. So there are internal APIs, what you're exposing from your application. There are external APIs, things that you need to consume. And someone says, well, all you have to do is use the API, and that sounds really easy until time comes to actually use the API. So just to kind of give you some background, I recently went from oil to gas in my house, and they put this nice thing in here. And if you notice up there, there's those little labels on the pipes. So this is a close-up of the labels. Now, why do the pipes have labels on them? So it turns out that the same white PVC pipes that they use for air intake and air exhaust on a gas heating system up in Massachusetts is exactly the same kind of pipe they use for plumbing. And in the town that the house is in, one of the do-it-yourselfers put in a new toilet. And he ran the sewer pipe and saw this nice white PVC pipe without labeling into the air intake for his brand new gas heating system. And so very literally, the poop hit the fan. So what we want to do is we want to talk about not, when you go to deploy, not putting the wrong thing to the wrong thing. We want to talk about kind of avoiding that. So the overall story arc, there's a little pun on arc, right, is we want to talk about the REST basics. We want to talk about dealing with incomplete information when not all the APIs are fully documented. We're going to talk about some of the tools in dealing with REST APIs, including Postman and Fiddler, and also the things we've done with the Autonomous REST Connector. We're going to talk about what happens when you get complex data back, not just a nice simple table, but things with nested arrays. We're going to talk about dealing with change, because I've heard that occasionally people change their applications, and so the API changes. We're going to talk about what we do for performance. So you have a large database. You do not want all 15 million customers to come back on every query. We're going to talk about security, and then when things don't go right, and then finally we're going to give a few extra demos. And throughout this, we hope to have some demos. So, why choose REST? There are a lot of good reasons. One is the same technology that REST is built on is what the internet, what the web is built on, right? And there's been a lot of energy put into making the web go really, really fast. The nice part about REST is we are able to leverage the same technologies that have been proven and deployed in browsers. So compression, caching, things like that. Another reason is it's simple enough for an intern to implement. The protocol is very simple, and you add it, you get some value right away, and then you can expand and you can get incremental values. So unlike some protocols where you have to build the whole thing before you get any good out of it, with REST, you can deploy progressively. And all the cool kids are doing it, right? Almost every application has REST in or REST out. The tools to deal with it are widely available and free. So there's a few of the applications that do it. It's probably hard to find a service now that doesn't expose REST in some way. And in addition to all these, there are a lot of public APIs. So for example, the United States Geographical Society has a REST API for earthquake data. You can get weather data from a variety of things. So if you deal at all with disasters, you can see incoming weather patterns and you can see what's just happened. So let's talk about the basics in REST. The protocol is HTTP or HTTPS. The verbs, there's a very small vocabulary of things you can do. And the payload is generally JSON, occasionally XML, but JSON has pretty much taken over. JSON compresses slightly better. And the verbs correspond to actions that we're familiar with in dealing with databases. So, for example, get is very much like a find or for each, right? Or a select in SQL. So, and the general pattern is get and then the entity. So get/customer should do the equivalent of getting all your customers, for each customer, or select star from customer if you speak SQL instead of ABL. If you want to get just one of something, the general pattern is get entity/key. So that's equivalent to find customer where ID equals key, or select customer where you just get one row. And then if you're doing something else besides if you want to get query in another way besides just getting it by the primary key or the primary ID, we use the query syntax. So for example, in this case, if you were dealing with the old Progress demo database from many, many years ago, one of the vendors was UFO Frisbee, and since I spent the first 17 years of my time at Progress in OpenEdge, you're going to see, we called it Progress back then, you're going to see references to that really old database that I dug out from my machine from Progress version 6. But in this particular case, we're saying get all our customers, but filter and return only the ones where the name is UFO Frisbee. So that's the general pattern, where you put more complex queries in a query string. If you're searching just by the key, one primary key, you just put it right in the URL. So another operation in REST is post, and post is similar to a create or an insert. And when you deal with post, there's a JSON body which contains the actual data. So if we're going to create a new customer, we do something like post to /customer with that JSON as the payload as what we call the entity inside the HTTP request. And it would be equivalent to doing that or create an assign in ABL or an insert in SQL. In addition to being able to get and insert data, there are also REST methods or verbs that we use to update. So there's put and patch. So technically, when you do a put, it's equivalent to doing a delete and an insert so that anything you don't specify gets its default value. In practice, when people say put, usually they mean patch, which is just overwrite the values that I'm sending. So we're going to pretend that they're both the same for purposes of this discussion, that when you do a put, just the fields that you list are the ones that are changed and we don't touch any of the other ones. A lot of REST implementations confuse the two. So here's an example. We're going to do a put, and we're just going to change the sales rep from, was it DKP to SLS. And so here we're going to say write to customer number 27 and change the sales rep. So we do a put with that as our payload against that endpoint, and it would be the equivalent to doing this. And then delete. This is a pretty easy one to figure out. If you haven't been able to discern the pattern by this point, then you're probably an intern. All right. So let's get a quick demo. We're going to turn over to Phil, and we're just going to see Just a very simple way how this would work if you were using the Autonomous REST connector, just to get an example.
Yeah. Kind of want to set the stage for. What am I doing? I'm not mirroring anymore. Which way is it? Set the stage for the rest of the demos. All right. So the idea here is, how many of you guys have written REST APIs before? All right. So we're going to blitz through some of this. But just to level set our expectations, right? The idea is that we're working with a sports database. It is from a relational database, so it's rectangular. You could expose that with JSON, something like this. This is hitting, for anybody who's particularly devious, this is running on a service on my laptop because I am inherently distrustful of conference Wi-Fi. But it is, in fact, a live REST endpoint, just very localized. And so that's what you can have. You can pull it up in your browser and see it. And that's the basics of it. I mean, you see Yogesh go up there and say, hey, MajorLeagueBaseball.com and pull the standings down. This is the raw data that's the sort of raw data that would be underneath that. The other thing that we'll see a few times throughout this is Arc. So towards the end, I'll be showing it in a more user-friendly way, like through Tableau or Power BI. I wanted to show you something somewhat quick here about what we're doing. So I can actually run this. Let me make this bigger. And I don't care about the console right now. So in this simplest of cases for something like the Autonomous REST connector, this is a JDBC instance of it. I can tell the driver, I'm telling it to sample that endpoint that I showed you in the browser. All of this has happened already. Everything I'm about to show you, I just put breaks in there. So I don't want you to think that there's this crazy latency as I'm walking through this. But the driver went out to that endpoint. You saw there was no metadata. There was only data in that there's only data here. There's no metadata that comes back from the API. So the driver goes out though, it gets that data and it starts to sample it and try to figure things out. This is one of the downsides of trying to integrate data from a REST API is that even if you have a well-documented API, it's not usually done in a machine-readable way. So the driver, either using Autonomous REST connector or if you're doing your own for hand-rolled integration, you're going to have to account for that somehow. What we've done is we go through and we sample everything and we keep track of what we see. There are certain things that we can apply some heuristics and try to map. So the first thing we do is we map an endpoint to a table. We can kind of ignore this one. This is an auxiliary table that we create that contains some extra information. And you can see that we've gone and discovered every one of those fields and we've mapped them to the fields on the left. It's a field on the right. It's a column on the right if you're used to rows and columns. And then, of course, to make sure that you can actually get the information, you can do, this is, so JDBC is SQL-based, right? So you'll select star from sports customers, and right here you see Ron Ferrante, I believe, who's our first record here. Simple, straightforward. That sort of sets the tone for everything we're going to talk about going forward. All right, any questions so far?
Is it clear what just happened? So we took a REST API and we just treat it as if it were a table. Right. So, all right, let's see. Ooh, more buttons.
More buttons.
So some applications do a really good job at documenting their API. So there's this format out there called Swagger. It's been renamed Swagger 2.0. It's now OpenAPI 3.0. And you have this nice machine-readable description of what's going on. And of course, we know that every developer, as soon as they get the code working, updates the documentation so it is perfectly in sync. But just in case, occasionally you run into a developer that hasn't done that, sometimes when you get documentation, it reads kind of like this, right? And you start reading the documentation and you say, this has no bearing at all on what I got back. Sometimes it's close. In this case, if you haven't read about the turbo encabulator, it's worth watching the YouTube video. But you get documentation sometimes and you say, who are these people? Let's fire them. Sometimes you get endpoints like this, where the only thing you know is that Rita wrote it, and you get things called object, and the Java docs are entirely useful, telling you that it returns a value, that's an object. Or you don't even have that, and you ask around, you say, I think Rita wrote that. Go ask her how it works. So how do you deal with it? Well, you can, like I said, you can look at the documentation and hope it's accurate, right? The sentence is false. Failing that, you can go read the source code. And you hope that the source code is in a language that you understand or that you can parse, or that it's not impenetrable, right? So that's for those old-time IBMers, that's APL for removing all HTML tags from text. So you could get something like that. Maybe even worse, it's written in Perl, right? Perl is a write-only language, right? You can track down Rita, right? And then you find out, she resigned last week. Hey, somebody, has IT wiped her laptop yet, right? Because this happens, where the source is no longer in existence, right? Sometimes you can just poke it with a stick and see what happens, right? It's the way we find out what's in that big paper thing hanging from the tree in the backyard. Oh, they're hornets. And so one thing is you take a tool like Postman, and you start hitting the endpoint and you start querying it. So then the other thing you can do is you can start building statistics on the data. You can look at the data, fire various queries, and aggregate the results, right? And then you start to build a statistical model, and you see what is likely. And that's what the ARC does, what the Autonomous REST connector does. It builds this model for you. But these are all different strategies, and in different places, we use, right, to solve our problems, we use these different strategies. So if we actually have documentation that gives us a clue, there are some things we can look for. One is the documentation will tell us what kind of authentication. So a lot of third-party websites will do this. So let's use it for an example, Jira. Jira is very popular for tracking issues within a company. So we use it internally. We use it for our user stories. We use it for bugs if we ever had any bugs. I'm sure it's very good for that. We don't know that, of course. Okay, we have bugs. Years ago, we were at a conference, and we used to publish this bug list on paper in the old days in OpenEdge, and one of our customers, or one of our sales rep was talking to the Oracle guy, and the Oracle guy says, well, we don't have bugs. And then he says, well, confidentially, we have 3. So we also have only 3 bugs, just to be perfectly honest, right? But authentication is a big deal. You want to find out, are they using basic authentication? Are they using OAuth, right? How do I first get to that thing? Then you want to find out, if you have large volumes of data, you may not want all 50 million rows back. So the documentation hopefully will describe paging, right? Offset or something like that. We'll talk about paging in a little bit more detail later on. We'll want to talk, you'll look for, if you can find it, the semantics of the parameters. How do they construct the filtering? So if you don't want all 15 million rows, how do you say I want fewer than 15 million? How do I say I just want the customers whose name begins with U, for example? Is that possible? So these are all things you want to look for in the documentation if you're building endpoints. And you want to look at the response. Now, one thing you can usually get somehow, if there's any documentation at all, is a sample endpoint, and you can kind of get an idea of the shape of the data. And these are just some examples of common patterns. Sometimes you just get these little square brackets, and you get each row returned as one little JSON object. Sometimes you have a thing around it which names the entity, and then they're all inside it. And sometimes you get all sorts of wonderful stuff like how big the result set is and how many pages of data. And knowing this is kind of important because sometimes the REST service will change what you ask. A good example is Jira. If you ask Jira to return the first 1,000 rows, it may return 50. And the reason is it will decide that the payload is too large for its output buffer, so it will just truncate it. And so if you don't look at this other data, so say you decide your algorithm's going to grab 1,000 rows at a time, so you ask for rows 0 to 999, then you ask for rows 1,000 to 199, well, what you're going to get is rows 0 to 49 and 1,000 to 1,050. You have big holes where there's 950 rows missing from the first page, 950 from the second page. So understanding the difference between what you ask for and what you get is kind of a big deal. We discovered this the hard way because we use Arc internally because we use JSON or Jira internally, and we use it to measure our own metrics, how good a job we're doing at planning, how long a bug, if we ever had it, takes to close, stuff like that. So let's look at some of the tools that we can use to examine those results. So a quick way to get results when there's no special headers or authentication is use a browser. You see IE is going away, right, or Edge. So one of the big three. Now Chrome, Safari, and Firefox, they all have good tools for looking at web pages, right? So you can hit, like in Chrome, Control-Shift-I, and you get up the inspector, and you can walk through the tree and see what you got back. And all three of these, and also Edge also will usually present your JSON in some sort of format. So you'll get something that might look like this. So it's useful because you see, it tells you up there, you got results. But actually figuring out what all this stuff does is, is a little hard, but you can figure it out. This is not something that's beyond any one of us. So a slightly better tool is Postman. So you guys use Postman, right? So Postman's a great tool. It started as a Chrome plugin, and now it's a standalone app. It's got all sorts of neat things, like you can save libraries of APIs, and in fact, some sites now you can download from them a catalog that has all their APIs already in Postman format. It makes it very easy to test against. Postman lets you issue requests. It lets you inspect the results. It lets you modify the HTTP headers, play with different types of authentication. It's got helpers for all this stuff. So you can try and figure out how to get to the data that's in there. And so here's a screenshot of Postman. So we can see, at least here, our JSON's indented. We can kind of see the shape of the data. We have up there what our status was. We got a 200 OK, how long it took. And then over there it says we have 7 headers. So let's look at the headers. All right, we were very nice in our service. We said it's JSON with a content type, and we see some other stuff. And from this you can see that this thing's being hosted on Amazon. So it's a useful tool. We use it a lot internally to figure out what's going on with certain websites when we're doing development. Another tool is Fiddler. Does anyone use Fiddler? All right. Fiddler is from Telerik or Telerik, depending on your accent. It's a great tool. It overlaps some with the usage of Postman. It's very convenient because you can use it as a proxy and you can intercept the traffic going back and forth. So you can watch the conversation between your client and your server. It's good for figuring out why the authentication isn't working the way you expect. You can see and the other thing that's kind of neat is you can insert it between an application that's working and you can watch what it's doing. So if you can't figure out the authentication or the paging mechanism, but you have some other app that works, you can set it up as a proxy. You can point the app at that and point it at the other thing, and you can tunnel through it. If you need to configure it, to do it, there's some instructions on the website, but also this is what you would do in order to do it with Java. So this is what you take this certificate from Fiddler and you can export it. You get this little .cer file on your desktop, and then you do that command in Java and answer a couple questions. And then if you do these system properties in your JVM, now it will let you do inspection. It'll actually decrypt the HTTPS payload, so you can watch even encrypted traffic go back and forth, which is really awesome when you have to debug stuff, right? It's easy enough with HTTP because it's all plain text, but if it's HTTPS, without something like this, the stream is just encrypted and impenetrable. So this is a very useful tool. We've used it. So I'll show you a screenshot from Fiddler. Sorry, that's a wrong Fiddler. That's a Fiddler on the roof. Let's try the right Fiddler. So here's a screenshot from Fiddler. And this is the same, if you look over there, you can see the same little cryptic Amazon domain name that we're going against. It's the previous session. you can see the HTTPS requests out. You can see it tunneling through Fiddler, and then you can see the endpoints being requested there, and then here's the response coming back. And we can decode the whole thing. So, Phil, would you be kind enough to do a demo?
Sure. So we're gonna hit. You actually covered Postman pretty well, but I
take it all back.
You take it all back. I'd love to say that you were wrong, but oh, there it is. All right. So and I don't think I can make this huge, actually. Let's see if I can. Oh, look at that. Thank you, Postman. All right, so we went over the basics already, so I will go quickly here. But this is, you can see it's the same body that you would have seen within Chrome. There was nothing else interesting going on with this request whatsoever. No wonderful headers or anything that we sent. You can see a few came back. Nothing particularly interesting beyond the content type. But then there are other things we can do. You'll see these things a lot. Those of you who have already used REST APIs will see that. Anybody who's used Google, I hear it's gaining popularity, might have seen that up in their title bar as well. That's a common way of sending parameters. And in Git, you would put it up there. You also see in APIs a lot, we talked about a post. We have run into a number of APIs where in order to pass parameters up to the API, you'll actually send a post with the parameters in the body. Sometimes that seems to be a stylistic choice. Sometimes it's because the input data is actually really big and you can't have your URL get that out of hand. I tried to also just show sort of a variety of use cases or APIs that we might want to run into. This one just makes me giggle. This is an API, a public API called Alien with a Y. It's sentiment analysis. It's an open API for that. So you can say, you can pass, I could either type in the parameters up here or Postman's friendly enough to let me type them up here. And I can do something like, okay, well, let's see, I went somewhere and I got a review of this. I can edit my parameters in there. You can hit send. And I mean, there's not going to be a test on what Alien does, but you can see it's sort of thought that, hey, that seems to be a pretty neutral opinion. Waffles. That's not a very good review. It's not a very good quality review, but it's not really sure if that's good or bad. And you can pretty quickly go into things like, okay, well, I'm going to change here. And this is one of the ways that you can kind of figure out how these APIs work. This one, it's sort of a quick gimmick. Evidently, it keyed on that awful waffles is probably a negative review. But sometimes your API that you're trying to connect or you're trying to integrate with your app, it might behave differently depending on what input you're in a more substantial way than that. So that's helpful. The other sorts of things you can do with this, this is an example of connecting to Yelp. Yelp uses OAuth 2, I believe. And so you can sit here and set the authentication that needs to be used. You can grab an access token from Yelp's developer website, right? So you can't just guess that, right? But you go to their site, you register, you get a token, you can just plunk it in here, and you can start figuring things out about how to integrate this into your app, what calls you might need to make. A lot of times when we're using Arc, even if we're trying to figure out exactly what needs to be done, this is a pretty good way to test things out, especially when authentication comes into play. And then down at the bottom, you'll see the results. This one had a sort of a URL encoded. That's the progress location in Morrisville, where I work. And I think that was, okay. So the other one I wanted to show you briefly, this is another entry from the sports database, sort of a mangled version of that. So the sports database, again, I told you it's all sort of rectangular. For a few demos, for a few slides that you're going to see in a little bit, we're going to talk about complex data. And so I wanted to sort of get you familiar with this, but also to show you Arc as a way to inspect it. So you can look through Postman, and it'll show you the actual data that's coming back. All right, that's fine, but if you have thousands and thousands and thousands of rows, that doesn't really give you you can't really get an overarching view of what the data might look like. You get a pretty I mean, you can, I guess, if you have a lot of time and a few sheets of paper to write it all down on. But the other thing you might want to do, what I'm going to do is, so I'm just pointing at that endpoint. The same thing running locally here. I referenced that configuration table, our sort of auxiliary meta table, meta information that the driver kind of collects. You should recognize this structure. This looks a lot like the data that comes back from that endpoint, but you'll note that there's no actual result data here. These are all metadata information. So as soon as I connected, ARC went out, it sampled all that data that came from that orders database, and it started doing type detection and metadata discovery, and it can write all this stuff down. So if you were looking for a generalized view of what sort of data does this endpoint have, you can look at a few records and try to do that inspection sort of manually, or you could run a tool like ARC, which will go ahead and interrogate that endpoint, and you can see, oh, well, customer numbers always appears to be an integer. Price seems to be a double. It'll do some type mediation if you have different types. I think we'll get into that a little bit later. But this is a useful tool for doing that as well. Which I guess brings us to one of our first sort of breather moments here. We got through a fair amount of the beginning sort of REST, how you use it, what it is sort of things. So I want to give an opportunity to maybe answer some of these questions. So I know a bunch of you said you're writing APIs already. Some of you are probably integrating them with your data already. What tools do you use? I mean, I know there was Postman already we talked about. Are there other tools that you find particularly useful that people might appreciate a recommendation for? Yeah. I'm sorry? Perp Suite? I've never actually heard of that. Okay, it's a lot like Postman. All right. Yeah.
Use apiary briefly. Auto documents and create some test cases for your API and creating it. I don't use the short.
So apiary.
Yeah.
We're just repeating it for the recording. Yeah.
Oh, forgot. Yes. Yeah. There's a number of those that, due to the nature of what we were doing, we weren't really creating the APIs, so the test case ones are interesting. So yeah, if you're exposing your data, yeah, something like that would be very useful. All right.
Anyone use Wireshark? Wireshark's kind of overkill. We just found out, that Progress just bought Ipswitch. They happen to live in that world. We inherited some very, very capable Wireshark engineers. So we're really looking forward to picking their brain. So.
All right, so I want to talk a little bit more about the data that you might be getting back and how you might want to expose that, how you make that useful to your application, or if you're providing data, how your customers might. So there's some considerations here that if you're exposing data via REST API, it might impact your design decisions. First, we're going to play a game. One of these things not like the other. Here's a hint. It's that one. Everything else is a table. So data comes back. This is how it comes back from REST. We've seen that a bunch. I know I'm hitting that numerous times. It does not usually come back like this. You might have a picture embedded, I guess. It's a wonderful shaker trestle table. So for some APIs, like the simple one I showed you already, you might get this sort of pseudo-rectangular data where you have a record and it's all nice and neat and it's a simple array. A lot of folks who are doing, or maybe writing REST APIs for web apps and things like that, they might say, well, why would you do that? Right? I mean, that's not probably domain-driven design. That looks like something relational, which is kind of weird to put in a REST API. If you think I'm talking crazy, that's fine. If you see this all the time, that's great because you already know that a lot of times these REST APIs are just fronting something relational anyway. Or the one that we see a lot is you'll have some sort of reporting engine. And so maybe the native data isn't stored in a particular way, but the but the sort of enterprise internal data layer, they've written a few canned apps and have exposed those via a REST API. We see a REST API put on top of Elasticsearch. And I think one of those, they were actually searching over a Mongo repository as well. And so we see that sort of use case somewhat frequently. So it's not unusual to get very sort of well-behaved data like this, even though when you look at a lot of the public APIs, almost none of it really looks like this. With the exception of a lot of the government data, probably because of how it's warehoused.
Right, is rectangular here.
Yeah. For other types, you get this, something that is as arbitrarily nested as this. You get this really complex data. And so what it comes down to is it's a pretty well established pattern of how to handle rectangular data. But this nested stuff, a lot of apps don't handle that particularly gracefully. And so that's why, especially if you're trying to create something generic or you're trying to make your user's life easier if you're writing your own API, you might want to be a little bit careful or at least aware of what you're asking users to do. If you're trying to expose data for custom analytics, so you bring your own analytics tool, something on the right here might be a bit optimistic, unless they happen to be our customer, I guess. I did not just plug that, I swear. So I want to remind everybody a little bit why you might actually come up with that data, because if I'm going to stand up here and say, oh, well, all this analytic tooling, it can't really handle it particularly gracefully, it sort of begs the question of why. And I already mentioned sort of domain-driven design to a certain extent, but it models your actual, the real world, the relationship semantics that you might already have. This, for example, is a subset of that orders database. So every order is going to have a customer number and something, where you're going to ship it, and every order is going to have a list of items in it. So that's very realistic, right? The other reason to do this is it keeps related data together. This is, if any of you are familiar with NoSQL philosophy, this is directly related to that. You want to keep the data that users are going to want at the same time. You're going to want to co-locate that, right? If I'm going to ask for orders, chances are I'm going to want to know where I'm shipping that order as well. Or if I'm going to ask for some top-level order things, chances are I'm going to need the items in that order. So the idea is to prevent unnecessary round trips for the data. You store it all together. I can issue one query and get all this information at once. It also helps with consistency to a certain amount, in that I just have to update a single block of data instead of hitting a couple of different endpoints. One for orders and one for order lines, like we might set up the tables in a relational database. There's another reason, which we saw in some of Tony's slides there. It's very frequent with REST APIs to see this sort of metadata, where you might have, up here at the top, this is information about the execution. So you get, if the HTTP request succeeded, you should get a 200. It should tell you okay. But that doesn't mean that the execution behind the scenes was actually successful. And so sometimes what you'll see is you'll get a 200, but as somebody who's integrating that data into your own app, you don't know whether that is really counts as success. You just know that the HTTP request worked. And so a lot of APIs will return this sort of inner status. And they might, we've seen them expose a lot of metrics about how it functioned, how long it took, how many records total might have been returned, or how many records were touched, whatever the developer wanted to display at that particular time. You also see a lot of paging information, and then somewhere down in there you might end up with your results.
Sorry.
Sorry.
It was small.
All right. So what we do with that? We got to solve that some way. Again, we're primarily a JDBC and ODBC shop. We deal with SQL-based rectangles, right? And so if you're exposing data, your customers might as well. And so this is either something that they'll need to do, or if you have an existing app where you need to show some rectangular data, then perhaps you'll find a similar algorithm, or just use Arc. So the question is how to turn this into a series of squares, right? So it's a process we call normalization. This is This is a single record in that, a single document within the orders API that I showed you before. It has two simple types up at the very top. So we're going to just we're going to create a table. We're going to name it after our endpoint. It's the orders endpoint. So I'm going to just somewhat creatively name the table orders. We take our first two items. The first one looks an awful lot like an identifying key, so we use that. So we go to our next field, and it's not really a simple type anymore. It's an object, but there's still a one-to-one relationship there. So we simplify that. We just what we call flatten. We put that into the table that we have already. So now our table is up to 6 columns, 6 fields, and then we move on. The next one, though, is a little bit more complex. So that's an array. So we're going to need it's a one-to-many relationship. We can't just add. We could, I suppose we could. One option would be to add 3 different item number columns or fields to the orders table, and 3 different prices and 3 different quantities. But if you had an array of thousands and thousands of items, because this is a really big order, that table orders gets out of hand really quick. So what we do is we actually extract the order lines out into a child table, we call it. We copy down the primary key as well as this array position, this an array index, and that together that forms a unique identifier for items in this row or in this table, and you'll see we'll fold those down. If that's not as intuitive to you as other things might be, hopefully this is a little better. Wow, those colors do not work well on there. This data on the left would end up with a relational view on the right here. So you have all the data from these 4 are just copied into these columns on the right. And you can see these 3 entries in the order lines array end up as 3 separate rows on the right. The other thing the Autonomous REST connector will do, this order number column within the order lines table is a foreign key relationship up here, so you can still join. Are there any questions about how we do normalization? All right. So then what does that mean to you? Like, it's great. All right, now I have rectangles. Building blocks are fun. There's some things that, as an application, you might want to do in this. If you tried to issue there we go. If you wanted to issue some sort of join, you don't need to parse the SQL there mentally too much. If you wanted to get data from both of these tables, you could do a couple of things. A very sort of naive implementation might be that I'm going to get all the records from orders, which would be I'm going to select this once to get all this stuff, and then I want to get everything from order lines. So I'd hit that endpoint again to get these. Fortunately for us, Autonomous REST connector is a little bit smarter than that. Now that you've patiently sat there, now you can be too. You can just query this once because you already know that there's a relationship here, and so you know that they come from the same endpoint. You just do the one select or the one request to that endpoint, and sort of use a hierarchical reader to first read the first section here, the top block, and then iterate through this array. So that can actually be very fast. Gets rid of the problem. A lot of people say, hey, joins are really expensive. Well, yeah, this one's a join, except it's not really because it's only one request. So it's still pretty darn fast. However, if the data you want to join is across endpoints, this becomes a problem because you're already stuck with at least 2 requests anyway, right? One to the first one and one to the second endpoint. They happen to have this common value. So if you try to join, this customer data this order information with this customer data, it could, well, if it's really just one-to-one, it's not that bad. It's still only 2 requests. But if you had a lot of orders, this could scale up very quickly. And so what can you do? You could pull everything back. You could pull all of your orders and all of your customers and do the join locally, hopefully in memory. Excuse me. And sometimes you might need to. What you'd really like to do is some sort of optimization. So if you can filter any way, that would help. So you can give me all the orders. Maybe you're looking for, I want to know all the customers who've ordered things within a particular time span because we have this date field in the orders endpoint. So if you could push that part down, well, first give me all the orders within that date span and then look up all the customers. That seems like a logical way to go about it, right? But what that means, if you're exposing your data as an API, you have to be able to predict what your customers are going to be doing or likely to do so that you can provide them those filters. That's something that we often see overlooked in what we're trying to connect to, because a lot of times if you're trying to connect a BI tool to one of these things, maybe that's the second intended use for a lot of these APIs. They've designed an API for a particular reason. Now you're trying to set up Tableau or something to it. And somebody didn't have the foresight to give you those filters. Okay. So a final word on how you might want to design your data model to sort of help integration. I run the risk of saying that domain-driven design is a bad idea. I don't want anybody to get that impression. That's not my intent. It just it can complicate things, because if you're focused too much on what you're doing today, somebody down the road who might have a slightly different report they want to run might run into problems. So make sure you're designing it in a way that you can maybe add a parameter to filter down in the future very easily. Or alternatively, be willing to deploy a second endpoint primarily for reporting. All those things would be helpful in the use cases that we've seen. And then this last bit, this is a common problem for both REST APIs and things like Mongo. Anytime you start to have the power of these complex types, if you find your data model kind of looking like this thing on the right, step away from the keyboard, take a deep breath, and reconsider. Maybe this is right. To protect the innocent, I have not identified who this is, but this is a real data model that we've run into. Arc can handle it, but that doesn't mean it's pretty. And so be very careful with that. With that, it's back to Tony. You good? Oh, actually, is it?
No, you might want to do this one.
I think it was me. I think I lied. I don't know if it's just liar. My mistake. Still me. So schema evolution is a term that we've talked about. Over time, things change. If nothing else, we tend towards entropy, right? So what can you do as you're designing an API as a sender of data, right, as a provider of data? What can you do to protect your clients from future changes? Here are some things to avoid, bonus points for anybody who's a video game nerd. Avoid these pitfalls. Don't press forward before you're ready. Be careful about changing things. This is a common change that we see. Somebody thinks, oh, well, clearly I'm only going to need one contact phone number for somebody. And then, oh, wait a minute, people have multiple cell phones nowadays. And so they change a scalar cell phone number to an array. And they say, well, that was a tiny change, so I'm not going to version my API or anything. See what I said there? Version your APIs. If you don't do that, that causes the problems for your consumers, right? So be careful about doing that. What happens with the Autonomous REST connector, for example, or if you're trying to pull in data from someplace else, the best case opportunity there is probably to say, okay, well, I have to represent that as a string, because some of them are a simple string, if maybe it's an email address, and if it's an array, well, I can wrap that as a string too, and so maybe we'll just return a JSON string. I mean, you have to start munging things like that, or expose it maybe as a second column, but it starts getting very special purpose, custom design at that point, so that's a problem. This is essentially the same thing. Feel free to change its type if you really need to, but use a different name, please. And don't, it's agile, it's iterative development. Okay, I'm getting a new one here. We can make a big structural change. Everybody's going to be on the latest library. I promise you they will not be on the latest library. So be careful. Version your APIs. That will make everybody's life much, much easier. Some other advice we have based on problems that we've run into and some of our customers have run into. Everybody seems to have their favorite date and time representation. This is sort of a well-known problem. I mean, there's ISO standards about that. Try to use them. You can use milliseconds since the epoch also. I mean, that's kind of common, but this thing, don't do that. You're going to regret it someday, or whoever comes after you in your place of employment will. Some dates are very clear. Other ones are ambiguous. Numerics you need to be careful with, mostly just because, I mean, at least most of the instances we run into where this is a problem, some libraries that are ready-made to handle JSON seem to push these through a double type. which might not matter to your particular use case, but it might for others. Some things just won't round trip because you end up with rounding errors. So what you often see, if you see an API where all the numbers are quoted, somebody probably ran into this problem. And they said, I'm going to get around that just by passing it through the processor as a string, and then I will deal with it on both ends.
By the way, Facebook sends them both ways, quoted and unquoted, just to make sure for their IDs.
All right. As a client, what can you do? Unfortunately, not a whole lot to protect yourself. It really just comes down to hitting those unit or those corner cases. You've got a switch statement. Make sure you have a reasonable default. Things like that. But these are some of the changes that we see somewhat frequently in our short time working with this. You see IDs that maybe they began with just an integer or a big int, and then suddenly they realize, hey, maybe I should use a GUID for that, and then they didn't change a version or anything. That's pro tip. That's not an integer. Surprise. The other thing you can do is your app can. What we did with Autonomous REST Connector, what you could do is you can come up with some smart formatting. Things come back as a string. You'll note that orders had a date column. That comes back as a string. We just knew to interrogate that and say, hey, every instance of this looked like a string in this particular or it looked like a date in this particular format. So you try to help somebody out. It's not necessarily going to protect you, but it will be helpful. But that's where the type inference comes from. See what you can do. You might have to start returning things as strings. Also, use your versions. Be cognizant of that and check them. Now.
Can I have my turn now, please?
Now it's your turn.
Okay.
You're so needy.
I'm a developer. Of course I'm needy. We're just children, right? So let's talk about performance. The good news, your intern has come in. They have put a REST interface on your database, and now your entire database can be queried with REST. The bad news, your entire database can be queried with REST, right? So all 15 terabytes comes back in your first call. So you essentially have this. So I don't know if you know the history of at MIT, they do what they call pranks. Well, one prank one year is this showed up on campus where they hooked a faucet to one of the fire hoses, and they actually got it to step down enough so you could drink from it. And now that if you tour MIT, that's enshrined. They actually dug out the the hydrant and moved it indoors. And you can see up there's a little thing about it. But that's like what can happen, right? You don't want to try to drink from a fire hose. So the typical strategy that's used is paging. And there are a couple of different ways of doing it. One is you tell it how big your page is and say starting at row whatever. So starting at row 0, give me 1,000 rows. Starting at row 1,000, give me 1,000 rows. Starting at row 2,000, give me 1,000 rows. The other way that's fairly common is you tell it how big the page is and what page number you want, right? Page 1, first 1,000 rows, page 2, next 1,000 rows, stuff like that. Yet another way of doing it, so just an example here. So SpaceX has their website and they do it. So they have limit and offset as two of the parameters you can put in the query string. The limit is how big the page of data is, and offset is a starting row number. Another way that's fairly common is cursor driven. So when you say for each customer, right, there's a cursor, an index cursor that's implied, and as you step through and you iterate through the loop, you get your next one. In SQL, if you do a select statement, you can have a cursor on it and you can fetch one row at a time. So some REST interfaces similarly have this. For example, if you go against Facebook, what happens is you query, you get your first page of data, and then you have a pointer. And so to get your next page, you take that pointer in your response, and you ask for that, and that gives you your next page, and you get another pointer, and you keep going through like that. So there's some reasons, there's some caveats if you do paging, and that's stability. So REST ain't ACID, right? So one of the problems is what happens when people are changing the database while you're paging through it. So if you imagine we have our table that looks like that, starting at row 0, all the way up there to row 2000. Those are our keys. So I'm starting at row 0. I get my first 1,000 rows. I get keys 0 to 999. And Phil, who's evil, goes and deletes one of those rows Now, when I get offset 1,000, I'm actually getting rows 1,001 to 2,000, so I have a hole in the data that comes back. And the opposite problem happens when you insert. Right now, when you skip through, you think you're getting all your records, but you have holes in it because it ain't stable. So some sources like Salesforce, they solve this problem because they create that cursor. And you can't ask for this piece of rows and this, this section of rows and this section by offset. You just get the next ones, and they let your view of the data at least be reasonably consistent even while there's activity on the table. So you don't get things where you get to the end and you don't have 100%, or you say you have 500 rows and you get 498 or 502 and blow out something. So see Phil Evil laughing maniacally as he's deleting records while I'm trying to do my demo. So another issue in dealing with large amounts of data is that it's good to put some sort of filtering mechanism on. But if you're going to implement a filtering mechanism, try not to boil the ocean when you design it. So generally, the simpler the better. Every developer wants to implement their own query language. I'm sorry, it's just true. I have done it. Please resist the urge. Do you really need all those operators for your use case? If you really need to push down queries, instead of inventing your own, consider using something like OData. OData lets you do REST, but it lets you do structured queries. It's semantically equivalent to SQL or the ABL in the expressions, right? You can push down substring and comparisons and things like that. The nice thing is there are libraries out there to put OData interfaces on your application. So there's one you can get through NuGet for .NET, Olingo for Java. There's a nice standard out there, odata.org. They have a bunch of examples. OData 4 is reasonably well thought out. There are a lot of test cases, there are a lot of examples. It's used by a large number of applications. So it's a good way to go for that. But really, most of the time, people are interested in just simple filtering. And since everybody's not going to change their app to work on your particular query language, sometimes simple ones are good enough, right? So to use our example earlier, to get all your data, you say what your server name is and then your endpoint. If you want to do a filter, so we have a size filter, like get all the little items. So you just say size equals little. You do nice, simple, equivalent ones. And for most cases, this is good enough. If you want to use a different filter, we want to get all the green items, we can do that. And then, of course, you can combine them. I can get all the data on Martians by asking for little, green, and men, right? So there's a Lego store at Disney Springs, by the way. They did not pay me to say that. I just like Legos, too. But this is an example of filtering. See, it's not sophisticated. I can't do greater than or less than. I can't do in subset. But it's good enough for a lot of common cases. And so consider if you're not going to go all the way and use something like OData, which is well supported, maybe this is sufficient. All right. So the other thing we should talk about is caching. So the internet is really good at caching stuff. And congratulations, because you decided to use REST and not GraphQL, you can cache. Because caching only works with HTTP GET, and GraphQL is based on POST requests, so you can never use caching with it. So you can cache things, and there's clear standards on how to do caching. There's HTTP headers for cache control and expires. There's ETAG and if none match, and tools support this. So, for example, the Autonomous REST connector, we support caching. We support all these protocols and actually a couple others. And all the servers, all the common servers, Apache stuff, like NGINX, IIS, Tomcat, they all support these sorts of things. So you can take advantage of this. So that if some stupid application is hitting your website, your REST API 50 times a second, but the data is all the same, you can just say, my data expires every 60 seconds. And then they fetch it once, and then it goes, and they just use a local copy for that time. The other thing is compression. So there's no good reason not to use compression. We have heard people say, well, I don't want to use compression because it will slow down my website. So, yeah. That's like saying I want to drive to Florida because it takes me too long to get to the airport, right? The worst case performance for compressing stuff is maybe a 5% overhead on the web server, but chances are very good that that's going to be more than made up for in the time it takes to send you the data. And decompression is negligible. What's nice is because we've been doing compression long enough, that chips now, the primitives for compression are implemented right at the chip level. You know, chips, we have been doing this for a long time. The kind of instructions that are generated are the kind that engineers at Intel see all the time coming through. So these paths are optimized all the way down to the chip level. Some larger systems actually have hardware that does compression. So there's no good reason not to use compression. Deflate, it used to be called deflate compression. They changed the header slightly. gzip is a standard one. Google introduced Brotli, which is slightly better. And there's a implementation in a bunch of different languages there if you decide you want to do that and your framework for some reason doesn't support it. Some people say, well, my requests are small, it's not worth it. Or I want to put in some heuristics, so if my data is less than 5K, I just send it through identity, which means don't compress. Just don't do it. Just let the thing gzip. It's worth it. There's no good reason not to. A lot of good libraries. It's easy to implement. And it's transparent to the user. So we need some input here. So you guys who've done REST, what have you seen for problems? Have you noticed performance problems? Is everything magically fast, and so there's nothing more to talk about? And we should get you chocolate too if you raise your hand. So somewhere we have chocolate in the room.
I don't think we warned anybody.
So,
Where's our person?
Yeah. Yeah. A good example of latency is Jira, the application, because not only do they shrink your page size, but they have high latency. In fact, half this presentation probably applies to their API.
We learned a lot from this.
Yeah, we did. So there are a number of things you can do. So some of the things that we've had to implement in Arc to deal with that is we do speculative execution. So if you say select star from customer and the page size is 50, after we get the first page, if we see that you're getting the second page, there's a setting in there. We can say that as you're getting that, also fire off requests for pages 3, 4, 5, 6, and you can control how far ahead that goes. So that's one way of doing it. Where we see it is so for example, if you look at the Eloqua service, Eloqua is an Oracle thing. So what Eloqua is it's your data, well, all right, anything in the cloud is your data on someone else's computer, right? But it's your data on a bunch of Oracle computers. So what we found is while there's high latency, because there's a whole bunch of computers, if you issue 5 requests at once, they'll go like this to 5 different machines, and you get the payloads all on top of each other. So in that case, even though there's high latency, there's a lot of benefit to asking the question multiple times because you have different things filling them. So that's one example. Another thing that we found at caching is a lot of endpoints don't implement caching at all. They don't set the ETAG header, they don't set the expires header, they don't set the cache control header. So one of the things that we've implemented in Arc is you can say, I know this site doesn't have caching, but I'm going to pretend it does, and I'm going to make every page not expire in less than 60 seconds. And I can say that I'm going to set my cache size to 100 megabytes. And so I can cache locally even if the site doesn't do it. And so sometimes that's an option. So Corticon is embedding Arc, so you can do callouts, you can enrich your data for your queries. And that's one of the things they've noticed, that their own applications sometimes, because of its nature, it's issuing requests and the page may return 50 rows, but the first time they call it out, they only want the first row. And then they call it out and they only want the second row. And so they were fetching the same endpoint 50 times within a few seconds, or a fraction of a second sometimes. And so we gave this option so that they could say, well, I know that endpoint doesn't implement caching, but I know it's also, we're not talking about the stock market here. It's okay if the data is 30 seconds out of date. So we'll just set a 30-second or 60-second expiration. And if our queries happen to hit a bunch of related data that all just happens to be on the same page, we won't refetch that a whole bunch of times. So those are a couple of the strategies you can do. REST doesn't inherently make your database faster, sadly. I would like it to. I'd like to answer all your questions. Yes, just put REST on it. Does that help at all? Some of the strategies you might do?
The simultaneous request, if you make like request on page 1, page 2, then just go ahead and send out from 1 to 10. If you get a bunch of empty responses back,
Yeah. Sometimes you'll overshoot, right? And you'll ask for 10, but there's only 9. And the last one will just throw it. The thing in that case, if you're going to do speculative execution, what you have to be smart enough to know is that if you get an error, it may not really be an error. It just may be that you ran off the end of your data. Right? And so you have to be a little smart about that. We're going to talk about HTTP status codes a little bit later on.
Keep moving then. Probably need to keep moving then.
Okay. So let's talk about authentication. So good news. What's the good news? You put on a REST interface so the whole world can see your data. The bad news, the whole world can see your data, right? So say goodbye to your database. So what are you going to do? So let's talk about some authentication. So there are a few different things that you should think about with the authentication. One of them is no authentication. Some endpoints, you just don't need it. There's no good reason to put authentication on the United States Geographical Society earthquake database, right? It's public information. Sometimes you need some authentication. So basic is fairly good in those cases, like just username and password. So Disney exposes the Marvel Comics universe as a REST endpoint. You can go to marvel.com, you can get a key. The only reason you need the key is so that they have some control over pulling the data. There's no real security. I mean, you don't care whether it's, this superhero, you don't care that, well, what do you mean there's no Superman in there? But so, it's a wrong universe. They don't really care about what you're querying in there. So sometimes that's good enough. A lot of times you'll see an application will have more than one authentication method. So for example, Jira can use BASIC and OAuth 2. BASIC is very convenient for while you're doing your development. It's easy to automate testing. But then when you actually deploy it, you may want to have all your users use OAuth 2. Stay away from Digest. It's no more secure than BASIC. It's just more complicated. Stay away from OAuth 1. OAuth 1 is OAuth 2. It's the version 1.0 of OAuth 2 with all the bad things that implies. OAuth 2 is actually more like OAuth 3 because usually it takes version 3 before you get things right. But OAuth 2 is really good. It's much simpler to implement than OAuth 1, and it's just as secure. Google, for example, everything is OAuth 2. I think LinkedIn is OAuth 1 needlessly, and they have an OAuth 2 now. Another thing is single sign-on, so Kerberos, Active Directory, something like that. Stay away from the bottom one, other. Please do not implement your own security. No third-party tool will be able to access it. And Bruce Schneier says that anyone is smart enough to create encryption that they can't break. However, that doesn't mean that anyone else can't break it. So use a proven one. We recommend OAuth 2 or one of the single sign-on ones. So does that cover what you guys have seen for authentication out in the field? Is there anything else that that you might want to use that's not listed there? That's a very good answer. All right. So I'll just keep going. Yeah. Let's talk about error handling. Everything is not okay. So make sure that you don't just return the 200 okay no matter what your answer is. Please use the codes the way they're meant to be used. If there's an error, sometimes we want to retry. So one of the things that we've implemented in all our HTTP-based drivers, including ARC, is the concept of web service retry. So sometimes the answer, it's a Microsoft answer, right? If it doesn't work the first time, do it again. Reboot, do it again, right? So sometimes you want to do that. What you do with errors and how you decide to do it, how you decide what to do with them is kind of a complex thing. So this is just a quick overview of the HTTP errors, the way they're meant to be used. So the 200 in friends means all is good, right? So 200 okay, our favorite response. It means you got back the response you were expecting, and there's some payload. Sometimes you'll get no payload and you'll still get a 200. Technically, that's not right. You should have a 204, which means everything's okay, but I didn't tell you anything other than it's okay. Often, if you issue the delete verb, you get a 204 back. You'll get another status code with a payload if there's a problem, but either one of those usually means what you just did is fine. Sometimes people don't check for the 204, they get the 204, and their app crashes. So just where 200 in friends means everything's good. 300, somebody moves something. The one that's most common is move permanently. That's a really good one to think about, because how do people implement REST in their companies? So let's step back a bit, and we're a company. We have this big legacy system written in COBOL and RPG, and all the guys who maintained it are now retired. They're living down here, right? So what do we do to replace it? Well, the first thing we do is we get some interns in, we put a web interface on the whole thing, and then module by module, we start replacing subsystems, right? Turning it all into services. Well, so what's very convenient is if there's a web front end on it, we build a service and we just say redirect. So all the apps that were going to the mainframe website will still go to that same endpoint, but we'll now divert them to our other implementation. And then that way we don't have to fix all our apps right away. We can stage our changes. There's also a 304 that's using caching to mean you already asked me this and I already answered you. It's like the answer all us parents give. You know, I already said no. So when you ask for a page, if you keep track of the results, you can ask for it again later on, and you can send this checksum that they send. It's called an e-tag, and you send the request again for the same page with that e-tag, and if it's changed, it'll send a 200 with a new payload. Otherwise, it'll give you a 304 saying, just use the one I sent you before it's current. The advantage there is you don't have to parse the whole new payload. The 400 in friends mean you did something wrong. So 401 means maybe your token expired and you have to go fetch a new one. You're not authorized. Forbidden means I don't care what you do, I'm not going to let you touch that. 404 means it's not found, and we're going to dig into that with a little bit in a moment. And 429 means too many requests. So you've exceeded our throttling threshold. That's a good one to be aware of. Some sites, if you ask too quickly, will just return a 200, but will change a message saying don't do that. That's really rude because your app thinks it got good data, but it's the wrong structure. I'm not going to name AlphaVantage because that would be rude to actually name someone who does that. We do have to have a mitigation specifically for them. We have some overrides in Arc. So it's just something to be aware of. Watch what the thing returns under error conditions because it may not, they may just lie to you. And then the 500 in friends means it's not your fault, it's their fault. If at first you don't succeed, right, give up because nothing you do is going to fix it. 500 is bad. Occasionally, if you do the wrong thing, you'll get a 500 because you've crashed a server. That also is not your fault. Yeah. Dealing with 404, though, is a little bit tricky. So if I ask for a service custixer, a number 4, we don't have one, so we should get a 404, right? But it doesn't matter what we ask for. We don't have custixers. We have customers. So in that case, a 404 error is telling you, well, it's not there. But it may be that we have customers, but we don't have a customer number 4. That also is a 404 error, but that's not really an error. That's a query where we got 0 results. Right? So just understanding the difference between an error because you look for something in the wrong place versus you look for one of many somethings and there just doesn't happen to be one of those is a little bit tricky. And the funny thing is if I search for customer 4 using this thing, I'll get a 404, but if I search for it using a query string, I might get a 200 but 0 results. So understanding that those two things are actually semantically the same. So yeah. Sometimes people on that first case, instead of returning a 404, will say 403, meaning you're forbidden to go somewhere that we haven't implemented. It's kind of it's breaking the paradigm, but in a weird way it makes sense. The other thing to watch out for is bad JSON. This is a completely different kind of error. So some sites don't put the commas. They serialize each entity as well-structured JSON, but they don't put the commas between them. And so your JSON parser croaks because it doesn't know what to do. In the ARC adapter, we actually had to account for this. We have a thing called chunked. You can set flag on. It means they just sent you chunks of JSON and not actually well-formed JSON. Some parsers, like Jackson, are forgiving. They have various mitigations you can turn on and off to deal with stuff like this. Another problem is missing escapes. So sometimes they don't actually go and put escapes in when there's embedded quotes or other things. And that's kind of a nasty problem. And there's not really much you can do about this because there aren't deterministic ways to figure out where they should have gone. So that's the fault of the vendor, and sometimes you just have to complain. All right, so is this you?
I mean, you want to demonstrate something?
No, I want you to demo it.
All right. All right. So all of this has been around the idea that, hey, you're trying to get data integrated into something, right? We keep saying data integration. Right button. There are some sort of outstanding challenges. We got to some of them with the latency discussion earlier. But when it comes down to it, some of these REST APIs, just because of their nature, maybe their layered nature, maybe it's sort of a secondary purpose, they have some problems that if users are using something that's canned already, like some sort of business intelligence tooling, they might be used to a really snappy connection to SQL Server or something like that. So there's trade-offs. Yeah, we love being able to say, hey, we're providing you data access to something like REST. I'm sure you'll be able to, you'd like to say that to your customers as well. But that doesn't mean they're going to get the same user experience that they're used to. And it's important to realize that sometimes you can't necessarily do a whole lot about it. If you're doing a lot of ad hoc querying, if latency is an issue, our Jira instance, for example, is not the snappiest thing in the world. I don't actually know which of these is why. It's not my server, so I don't know what kind of hardware we're running on. Actually,
we're hosted.
We're hosted.
We have no control at all.
So there's not much we can do about that. So it might be something where it's just, a lot of these services, they're just, it's just a thin little REST API. We're gonna maybe it'll be underpowered a little bit. Some of them might be service call limits, the throttling that Tony referred to a moment ago. If they can only return so many rows per request, and you're only allowed so many requests per second, there's not a whole lot you can do about that.
Or so many requests per day.
Or so many requests per day. Yeah, we've run into that too. Try automating those tests. Yes, sir. So the most common thing I'm aware of is they force you to register for a key. So the Marvel example, they might do that. So you have to have an API key to use they don't really care about. They're not authorizing you to use it. They're not authenticating you necessarily, but they are tracking your usage. So I suppose you could be really devious and have multiple keys. There's probably some agreement somewhere that might not jive with, but
you could have all 1,500 employees in your company register and pool their keys, right? Because then you're within the limits, right? But yeah, but often it's by key. Sometimes it's by IP address.
That sounds like the voice of experience.
Yeah.
If you're only getting like 50 records per hour, they deserve to be
If you're only getting 50 records per hour, they deserve to be avoided. And
There's that. Actually, we also get back to the latency mitigation where we did things in parallel. We had to work with our. My advice for that situation would be become chummy with whoever is in charge of that system. For our internal one, for example, we had to. When we provided the functionality to do some things in parallel, sort of prefetch some things, we had to do it with a large asterisk and warning because, for their use case, man, I'm going to turn that knob to 11. I'm going to see how many threads I can get all at once. And Jira's already slow, and so they could have brought it to its knees pretty quickly. And so it's one of those, all right, parallelize just enough to get the performance you need without impacting your day-to-day operations. To do that, it's helpful to have whoever's either it's DevOps or an IT department or whoever owns that service to kind of vet your theories there. All right. The other thing that trips up a lot of sort of canned apps already is that some APIs require a where clause. Like, so some of those filters might be required, or if the parameter, like the customer ID, is actually in the path, you have to provide that where clause. Otherwise, it's an endpoint that doesn't exist. If you're writing your own app, you can account for that, but it's hard to communicate that to users because that's not there's nothing analogous to that in SQL. You can't do a get columns and say this is required to query this, and so some existing apps might fall on their face if you're not careful about doing that. When setting up Tableau reports in the past for things like that, you can sometimes get around it by turning off their auto refresh. Tableau likes to build things as you go, and so you might end up in a state where it tries to query something where you haven't set up a filter yet, and that can be an issue. So you might need to work around some things.
There is at least one vendor out there of the sort, not Salesforce, but like that, where you can't do the equivalent for each customer. You can't. There's no way to get all your customers. You can only ask for them by ID. So that means a lot of requests. But they mitigate. They say you can ask for 200 customer IDs at a time, but because of your usage limits, there actually is no way to get all your customers in one day. So.
All right. I want to do at least one quick demo here, and then open it up for questions. So start thinking. I have a few. Don't worry. I will keep going. I'll also be at the expo, so feel free to stop by and see these there too. But I did want to show you something. So this is a not entirely contrived demonstration. I know, shocking. But what we have, again, we have our customers database on the left. That's kind of being a stand-in for something like Salesforce, or if you have your own customer management system implemented. I'm using the sports database because that's what I have. I don't have credentials for Salesforce. However, the thing on the right, if you remember, that's what the Autonomous REST connector, that's its output. That's what it's inspected. This is one endpoint of Jira. That's one single endpoint of Jira. And so that's a pretty good example of why you might not want to just open it up in Chrome or Postman and try to figure out what's going on. As it turns out, our IT department does some queries based on this for our business analysts. But for they're actually warehousing things. What they end up doing, they hit I think we're about at 24 endpoints. So we can put all those endpoints into one of these REST files, we call them. And so we have something like 1,400 lines of fields, really, is the first order. It's about 1,400 fields across those 24 endpoints. And so you can point Autonomous REST connector at this file and have it describe it in a meaningful way. But to show what we can do with that, let me open up Tableau real quick.
So this is a mock with the Jira endpoint, but with sports database data. Those are our customers who are having problems?
Yes.
Ew.
So I'm going to do this quickly. So Tableau recently, just a year ago or so, much to my benefit, started supporting JDBC as well as ODBC. It's just a little bit quicker to demonstrate. So all I have to do, and I don't know how to make that bigger, and I'm not going to try to find out. All I have to do is put that URL, this one. I'm telling it to sample from our customers. All right, sign in. I'm actually going to want two things, so I'm going to add another connection. So this is the sort of thing that your customers might be trying to do if you manage to expose your stuff via REST. whatever you think they may be trying to do, I can promise that there's some guy like me out there who's like, I wonder if I can put that in Tableau. That might be a terrible idea, but I'm going to try it. So what I've done is I've connected those two. I've connected those two things. What Tableau does, I want to make it clear. I work for Progress, not Tableau. I do not claim to be a Tableau expert. So apologies if you are. Please teach me later. So what I've done is I found from the issues, from this data source, this one that's connecting to Jira, also sort of a clone hosted locally because Wi-Fi. I pulled this table over. I can then go to our customers' data source. And these could be ODBC or JDBC connections. And I pull our customers table. It tries to figure out what the join is, but since there is no actual relationship there, it kind of chokes on it. But I can tell it to do field, that's tiny. It is called field customer number from the issues table. And then on this side, I have a custom num column there. And so, hey, the little red asterisk or exclamation point went away, so it should be fine. And so now what you do with Tableau is you can do things like, so what I did is I told Tableau there how it could issue a join if it needed to. So I can then come from, let's see, the name of my customers are only, oh, wrong one. And hopefully put it up there. The names are only in my customer data table. So I can pull the name up here. I can pull the IDs, though. The defect IDs are present in my issues information there. And so just like that, so every time I drop, almost just like that. I have to tell it to aggregate, sorry. Just like that, every time I did an operation on this, Tableau generated some SQL and sent it to JDBC, one of those two connections. And so just like that, I have a count of defects per customer. And so I can look at that and, I don't know, optimize my business or do something somewhat useful. Where's my other one? This is sort of a fleshed out version of that that I was trying to get some more useful metrics, right? So this is the defect customer. This is defect count by customer. You can say, okay, well, year-to-date sales, these guys are paying us the most money. You can, time to resolution is sort of a business operations thing. Let's say you had a service level operation objective of saying 10 days to resolve any defect. Anything above that line, it's taken us more than 10 days to resolve. And so you can start doing this sort of reporting by integrating a couple of different things, a couple of different databases. With that said, I mean, I have a couple of different flavors of that if you're, oh no, we're doing on time, 5:15. I do have a couple of other demos like that. You're welcome to see them either at the expo or hang around now. If you have questions, though, I think now's the best time to take those. Yeah.
So one of the things that our organization is trying to do is we've got a bunch of different data sources, and most of them are file-based. Very few of them are based. And we're trying to aggregate, normalize, and then expose that as a API. Are there any tools, Progress or otherwise, that you recommend for that kind of use?
Sure. Do they happen to be in JSON?
No, they are XML, they're type-loaded. Generally, just sent to an FTP server. So we're more advanced partner or something over SFTP now.
I don't even remember how to spell FTP.
There's a protocol in there someplace.
Yeah.
So we have an XML driver. I'm not sure that it'll do what you want it to do. So, all right, the reason I asked about JSON is because Arc will actually just, the use case is some hosted REST API somewhere. You can actually just point it at a JSON file, and it will work as if by magic.
And do we have our product manager in here?
We do. He's hiding in the back.
Okay. So
He's one step away from a hammock.
let's just talk hypothetically without delivery dates, I think. So It just,
He's a product manager. He's going to promise it no matter
Yeah.
what.
all right, because we said at the beginning that we're going to entertain ideas, right? And think about what in the future. So we have talked about, so Phyllis said we can aim, if you have a JSON file on disk somewhere, you can just put the file URL in and we can reach that. If we had a parser that would understand XML as well as JSON, that would get some of your use cases. And that is somewhere in our backlog.
Maybe we can write the integration to change the Python limited
Yeah.
and all stuff to JSON.
And then you can just point at them and consume them as if they were served by HTTP.
Yeah.
And then as far as
And then authentication is not an issue, right? Because they're just sitting there in a file system.
mapping fields, like say that one source has product number and another one has product ID.
Yes. So there's a couple of different ways to do that. If you happen to be using Arc, so this thing here, this is when you go and sample it, what happens is, or when you aim at an endpoint, and you say sample equals, what happens is we pull the data, we instantiate a schema in memory, and we present it all in one operation. So you don't actually have to go and configure anything. But one of the things we do as a side effect, we can produce this thing here, which is a configuration file. You can take this configuration file and you can rename things in it. So like, all right, if you just go in there and you stick a different name in the angle brackets, when we do the request or we look for the field on disk, we're looking for author, but we're presenting it in the dictionary or in schema as guy who wrote it. So we can use that to rename fields. Where we see that a lot is for example, in Jira, you have things called ID and key and name and description, but you also have custom fields that you can add, and they're named field underscore 01001, field underscore 01002, and we let you rename them. We actually have a way to plug in and pull their, they have another REST API which names all those fields, and so we actually go and do that for you in the Jira case. We'll go and we'll look them up and say that what he meant to say was not field 0001, but field time bug open, or estimated delivery date. But that's the mechanism we use. We can just go and rename columns that way. And anyone who feels underprivileged because they did not ask a question, everyone gets a trophy.
They also get chocolate. They also get chocolate from
All
Sarah.
right. Thank you for your attention.
Yep.
We hope
Thanks.
we've been helpful.